Yes, okay. So let's start today the area related to circles. Okay, area related to circles. In my last class, we have completed exercise number 12.1. Today we'll start exercise number 12.2. So here we'll first discuss few formula related to this chapter. Let us consider a circle. This is a circle, and this is the center of the circle. Let radius of the circle is small r. Radius of the circle is small r. We are considering 2 points. One is P and one is Q. So PQ is obviously a arc. Can you tell me what we call this portion? We have already discussed it. But what is the name of this shaded portion? Yes, very good. This is the minor sector and this unshaded portion is a major sector. Now, our task is how to find the area of this minor sector. If we consider this angle is theta. If this angle means the angle at the center made by this arc is theta, so how to find the area of this portion? Okay, now look. If you consider, let r is the radius. Radius of the circle is r. So what is the area of the circle? Area of the circle. So the formula is pi r square. We all know the formula, that is the pi r square. Now look one thing. This is the first line. If I rotate this radius through 360 degree, so it will cover the total circle, isn't it? If I rotate this, let me take a chalk. Okay, this is the radius OP. So if I rotate this radius through 360 degree angle, so it will cover the total area, isn't it? So if the central angle is 360 degree, so the area it will cover is pi r square, the total area. If the central angle is theta, so how many area it will trace? It will trace this shaded portion, means this sector. Okay, so 360 degree cover pi r square area. 1 degree will cover, if I rotate the radius by 1 degree, it will cover pi r square by 360 degree. And if I rotate theta degree, so it will cover pi r square by 360 degree into theta. We are just doing unitary method. Clear? Now this can be written in the form theta by 360 degree into pi r square. This is the area of this sector, minor sector. So formula for minor sector is theta by 360 into pi r square. What is the formula for sector? Theta by 360 into pi r square. So if you know the value of theta and value of r for any particular problem, we can easily calculate the area of a sector. Tell me, have you understood or not? If the central angle is 360 degree, it will cover the total area. Or if the central angle is theta degree, so how much area it will cover? That is the radius, that is the sector of the portion. Okay, So if the central angle is theta degree, it will cover pi r square by 360 degree into theta. So this is the area of this sector. Okay, write it. Now we'll discuss another formula. Next formula is, what is the length of this arc PQ? What is the length of this PQ? Okay, now look, we'll apply the same procedure. Look, if we rotate this radius through 360 degree, so this tip will cover this distance. Means its boundary. Boundary means its circumference. Okay, so if the central angle is 360 degree, so it will cover the total curve, means 2 pi r. Total circumference, that is 2 pi r. If central angle is 360 degree, so the total curve, total circumference will be 2 pi r. If the central angle is theta degree, so the length of the curve will be 2 pi r by 360 degree. If the central angle is theta, then the length of the arc will be 2 pi r by 360 degree into theta. So if I rewrite it, it will be theta by 360 degree into 2 pi r. So this is the formula to finding the length of the arc. This is the formula finding the length of the arc. Understood? These two formula, this is the basic two formula we have to use here to solve the problem. Okay? And now another proof. Suppose there is a circle. Suppose there is a circle with center O. We are considering a chord here. Okay. So tell me one thing, what is the name of this shaded portion? What is the name of this shaded portion? Yes, very good. This is minor segment and this portion is the major segment. So now we want to find what will be the area of this minor segment. What will be the area of this shaded region? How to find it? If the central angle made by this chord is theta. Suppose this is theta. How to find it? Now it has a formula. Okay. Let's give it a name, O, P, Q, and let this point is R. So the area of PRQ means this area of this minor segment. Area of the minor segment means PRQP. This is equal to area of the sector PORQ minus area of the triangle POQ, isn't it? Means if we subtract this area of the triangle from this sector, See, this is the sector and this is the area. This is the circle. So if I subtract this triangle from this sector, we have the area of this segment, isn't it? So this is the formula. Now if we consider that the radius of the circle is r, so we can easily find out the area of the sector POPRQ, which is theta by 360 into pi r square minus. Now the question is how to find out the area of this triangle POQ. How to find out the area of the triangle POQ. Okay, so I'm rubbing this one. Now my task is how to find the area of this triangle POQ, provide the central angle and the radius is given. What we will do? From the point O, we'll draw a line. Okay, let this is O, that point was P, PQ, this is S, suppose. OS is the line, a perpendicular line drawn from the center of the circle to the chord. Okay, now look, if this angle is theta, if this angle is theta, so can you tell me what will be the value of angle POS? What will be the value of angle POS if the total angle is theta? Yes, it is theta by 2. Why theta by 2? Because these two triangles will be congruent to each other. The first condition will be they are the radius, common side, and these two angles are 90 degrees. So the triangles are perpendicular to each other, so this angle equal to this angle. I mean this line actually dividing the total angle into two equal parts. So each part will be equal to theta by 2. So here the value of angle POS is equal to theta by 2. Okay, so this angle is theta by 2. The diagram is very small. Okay, I am drawing the same diagram by magnifying it. Okay, that you can easily understood it. Approximately like this. The diagram was like this, and this is the okay. So name was, this was O, this was P, this was Q, and this is the S, and this angle is theta by 2, and this is 90 degree. Now my question is, okay, is trigonometry portion has completed? Trigonometry. Going on. Okay, do you know what is the actually a formula of sine theta, cos theta, tan theta? What do you mean by that? Do you know that? Yes. Okay. So we are considering the triangle POS. This is the R. This is actually the angle POS. So in that triangle, if I apply sine of that angle, so what do you mean by sine? Sine means ratio of which two sides of a right angle triangle? Hypotenuse by perpendicular. Sine theta means Isanur. Oops. Yes, actually, yes. Perpendicular by hypotenuse. Okay, so the formula is perpendicular by hypotenuse. So what is the perpendicular line when we consider this is the angle? So if we consider this is the angle, so this side will be the perpendicular. That was the hypotenuse. Okay, so that means perpendicular means PS and hypotenuse means PO. So sine theta by 2 is equal to PS by PO. So that means sine theta by 2 is equal to PS by R. PS by R. So from here, what will be the value of PS? That means R sine theta by 2. So value of PS is R sine theta by 2. Okay? Now, in the same triangle, we'll apply cos theta. We'll find out the cos theta. May I rub it? Rub this portion? Okay, forget it. In the same triangle, triangle POS, we are finding out the cos of theta by 2. So what do you mean by cos? Cos theta? Cos theta means base by hypotenuse. So with respect to this angle, the base is OS and hypotenuse is OP. Okay, so OP means actually R. So from here, OS will be R cos theta by 2. So OS is equal to, this is R cos theta by 2. This line. Okay, so almost we have completed this. I am rubbing these two portions. Now we want to find the area of the triangle POQ. We know the formula is half into base into height, isn't it? So half into base. What is the value of the base? This is PQ. Into height means OS, which is equal to half into base. Okay, what is the value of PQ? Look, this is R sine theta by 2. That will also be R sine theta by 2. Why? Because this is the chord and OS is the perpendicular drawn from the center to the chord. So we know a theorem in class 9, we read it, that if you draw any perpendicular line from the center to any chord, so this line will bisect this chord. So if this is R sine theta by 2, that will be also R sine theta by 2. So the total length of PQ will be 2R sine theta by 2 into what is the OS? OS means the height, which is R cos theta by 2. Now multiply them. So if you multiply them, so it will be half into 2R square sine theta by 2 cos theta by 2. Okay, this is the area of this triangle. Now put it here. So half into 2R square sine theta by 2 cos theta by 2. 2R square sine theta by 2 cos theta by 2. That means theta by 360 degree into pi r square minus, okay, actually there was a formula. Okay, we'll apply this one. Okay, cut 2 and 2 and then put the values of this. But when we'll be in class 11, we'll learn a formula that sine 2 theta is equal to 2 sine theta into cos theta. This is the formula. So if we calculate sine theta, so it will be 2 sine theta by 2 into cos theta by 2. So in place of 2 sine theta cos theta, we can apply sine theta. Now look, there is 2 sine theta by 2 cos theta by 2. So we can write half into r square sine of theta. So this is the formula to find out the area of a segment. Otherwise, you can put this formula. Okay? So the final formula is theta by 360 pi r square minus half r square sine theta. Okay, now tell me, have you understood this derivation? Got it? Okay. So now then we are ready to solve exercise problem. Okay, so come to the exercise. We'll solve from question number 1. The questions are very easy. Even without my help, you can solve it by yourself. I am just showing you a few types of that. Okay, look, first question is, find the area of the sector of the circle of radius 6 centimeter if the angle of the sector is 60 degree. Okay, so let's draw a circle. Let's draw a circle. Let the radius of the circle is 6 centimeter. This is the center. So radius of the circle is 6 centimeter. And the angle at the center is equal to what? This is 60 degree. So we have to find the area of this sector. Actually, area of the sector. Okay, so let's find it out. Right. Radius of the circle here. Radius of the circle. Radius of the circle R is equal to 6 centimeter. Okay. The angle at the center. Angle at the center, which we denoted by theta, is equal to 60 degree. Therefore, area of the sector will apply the formula theta by 360 into pi r square. That was the formula, theta by 360 into pi r square. Now put the value. The value of theta is known as 60 degree by 360 into value of pi. Any value of pi is given? No, nothing is given. So we'll put 22 by 7 into r square. Value of r means 6 into 6. Okay, now we have to do the calculation. 6 is 36. So 22 into 7, there's 6. That is equal to 132 by 7. Now we have to do it. We have to do the calculation. We have to divide 132 by 7. That will give the answer. Okay? Just problem is very easy. You just apply the formula and you will get your answer. Okay? Okay, now can you move to the next question? Next question is, find the area of the quadrant of the circle whose circumference is equal to 22. Okay, so I'm rubbing this. So we have to find the area of the quadrant whose circumference is equal to 22 centimeter. So this is our circle, whole circle. Okay, and we have to find the area of the quadrant, any one quadrant. Okay, so we have to find the area of this portion. We have to find the area of this portion. And it is given that its circumference is equal to 22. This total circumference is equal to 22. Now tell me, what is the angle made by a quadrant, made by this quadrant at the center? What is the measurement of this angle? Yes, this is 90 degree. So central angle is known. Now just we need the value of r, mean radius of the circle. Okay, to finding the radius of the circle, the total circumference is given. Clear? So let us consider, let radius of the circle, radius of the circle is small r centimeter. We are considering it. Okay, so find the circumference. Therefore, circumference equal to We know the formula. The formula is 2 pi r centimeter. Now, according to problem, the circumference is given by 2 into 2. So, according to problem, 2 into pi, that is by 22 by 7 into r is equal to 22. So, this 22 and this 22 will cancel each other. That means the value of r will be 7 by 2 centimeter. That means radius is 7 by 2 centimeter and the central angle is 90 degree. So r is known, theta is known, we have to find the area of this quadrant. Okay, right. For the quadrant, radius is 7 by 2 centimeter. Angle at the center is equal to 90 degree. Therefore area is, put the formula, theta by 360 degree into pi r square. Now put the value. So theta means 90 by 360 into pi means 22 by 7 and r square means 7 by 2 into 7 by 2. Now do the calculation just. So 77 by I think 8. 77 by 8. Now just divide 77 by 8, you will have your answer. Okay, got it? Okay, now the next question. Okay, students, actually my time is over now. So, okay, no problem. Next day we'll solve from the remaining questions. Okay, from the next question. We have solved up to question number 2 today. So next day we'll solve from the question number 3. Clear? Okay. So bye bye. Thank you so much.